Hi, welcome to Groundwork. This is a podcast from McLachlan Corporation to talk about key material processing topics, everything from agriculture to mining to material recycling. We'll discuss the best ways to process the raw materials that power the world, because if it's not grown, it's mined. My name's Hillyer. I'm the Director of Global Sales for Mining at McLachlan. I've been with McLachlan for almost 3 years now, approximately 25 years in the industry, specializing in sizing, apron feeders, and crushing and conveying. And today, joined with me is Bevan. Bevan, you want to give yourself an introduction?
Hey, how you doing? Bevan McLachlan. I'm the Development Group Manager for McLachlan Mineral Systems, and been with McLachlan for about 14 years, I think now, and worked for McLachlan kind of all over the globe, UK, trips to the US, now back home in working for the Aussie team, which is, Mineral Systems for the globe. So, thanks for having me, Lee.
Awesome, Bev. No, thanks for joining me. And today we're going to be talking about all the different types of crushers in the mining industry. So essentially, straight up, we'll just get straight into it. What's the goal of crushing in mining? For me, I talk about this often. It's crushing big rocks into little rocks, but obviously it's a lot more complex than that. Bev, do you want to, I guess, give your insight into that?
Yeah, exactly right. Everything's way more nuanced than just turning big rocks into little rocks, as you say. I really like to try and dumb things down when we're talking about crushing, and I try and say that you've got sort of three kind of options. You've usually got the feed is the product, the feed contains the product, or the feed's in the way of the product. And if you kind of work out which one of those three you bin sit in, then you've kind of off to a good start as to what you're trying to achieve when we talk about crushing, because it sounds really simple until you sort of get into the weeds a little bit, I suppose.
Yeah, and I think what's interesting as well when you look at like different ores, whereas something like iron ore, where if you're trying to create a lump product, you don't want to create fines, so you've got to look at crushers that aren't going to create excessive fines, and that's same for like limestone, for example. If you're creating fines, that's loss of money because you're wasting your fines. But then when you look at things like copper and gold, where you're crushing stuff and you're grinding it down, to such a fine particle size, over crushing and fines creation is not a huge thing. So it's quite interesting when you look at that crushing side, depending on what the product is, depending on what the outcome is, whether you want to create fines or not. Obviously, that comes back into which crusher that you select.
Exactly right. And it's not just generating fines. I mean, sometimes the shape is also important. You're talking about whether you have slabby products or nice cubical products. And sometimes, circling back to where the feed is the product. So a good example might be aggregates, actually, where the feed is the product. You're trying to hit certain particle sizes. You don't really want anything that's too big or too small, so you're really trying to control your PSD. So over and under generation is quite important, because they're trying to hit drainage targets, things for ballast, and the size fraction that we're typically talking about here is down to kind of probably that 75 down to 10 mil if you're hitting those kind of products from traditional crushers anyway. But as you said, Lee, you then move over to like a more minerals-based application, where they're talking microns are typically where they're talking at the liberation size. So the further along, the further they can kick the can down the road to get to their liberation size is typically not wasted energy. So, a whole host of nuances there to consider right off the bat.
Yeah, definitely. And I think that, that is a nice segue into obviously what we want to chat about today is all the different types of crushers through the range that are typically used in mining operations. And I guess just off the bat, all this, jaws, impactors, cones, roll crushers, sizers, rotary breakers, they're just, and of course, not forgetting gyratory crushers as well. So, a whole range of different machines. And it's interesting how often that, I guess there can be a perceived bias on some of these machines. And then often, you see, like, I guess, well, the first thing I want to talk about is jaw crushers. Obviously, jaw crushers, there's hundreds of them, if not thousands of them installed around the world. It's been a sort of staple in the mining industry for many years. But, and it's a great machine, the jaw. Obviously, typically, two jaw plates, one fixed, one moving, in a compression type crushing action. But often, used often and very good, but sometimes used in situations where, you go and see when one's installed and you go, yeah, that probably wasn't the right choice. But yeah, I mean, I guess what's your input, Bev, on jaws? What's your thoughts?
I mean, we tend to think that a rock is a rock. I think that's the easy default position that people fall into. And sometimes the rock is fine, but then what's mixed with the rock is problematic. If you get high clay, for example, you're just going to gum up these machines, and you're really going to struggle with those types of applications. And I think that's probably fairly pertinent for a lot of mines globally. As ore grades decline, people are starting to push deeper and further along. You'll start to get below that water table, and so you'll hit more and more clay. That's just one small example of just where it's wrong. And we haven't even talked about, let's say that it was a good feed, nice hard feed without clay, but the jaw produces a slabby product or something like that. You've got an ore that fractures along really big slabs, and that can just be problematic for downstream transfer conveyors, downstream equipment. All of these things come into play. It's not just a one sort of size fits all.
No, definitely. Look, my experience with jaws is, if it's really hard, really abrasive, and it's low tonnage, a jaw is a good machine, right? There's no getting away from it. It's a good machine. It's typically low OPEX because it's a compression type crusher. So if you've got a really abrasive product, you generally your jaw or your gyratory is the go-to. But I've seen installations, two different installations. One where you got a high clay feed, sticky material, in Indonesia, sort of tropical location, a lot of clay, and the thing just bogs up. It bogs up, and essentially what they end up doing is just having high pressure water, just blasting this thing, just trying to clear it full of clay. They've got a grizzly at the front end trying to protect the oversize going in. The grizzly's blinding up. They're having to use an excavator to clear this grizzly. It's just a bit of a mess.
And what a nightmare managing that. So let's say it goes through your crusher, then what are you doing with your belt below that? If you've got all this high pressure water, just an absolute nightmare to deal with. I can imagine the stop starts for that plant. So your plant throughput's going to be shot. Yeah, real problem.
And what about wasted? Like, how much product are you losing, right? If you're blasting high pressure water through, it's all washing down, it's going into your sump. How much product are you losing there? When really, in a really sticky situation, if, perhaps right at the front end, if they'd looked at something like a sizer, I'm probably perceived as being biased towards sizes, right?
You're a sizer guy, yeah.
Let's not hide behind that. I mean, that's where, for me, you wouldn't or shouldn't pick a jaw. Yes, they're low cost. Yes, they're low OPEX, but for a sticky application, not good. I also had another experience in Western Australia where client was putting in some, this is what happens, right? It's a mine, they're putting bigger stuff. But actually, this was a plant in Western Australia where they were putting in these huge lumps into this jaw. And what would happen is, because the jaw, they didn't have a rock breaker or anything. So what would happen is, it'd go over the vibrating grizzly, fall into the jaw, and this thing would just sit there. And I was talking to the operators, and they were saying like, what they said is sometimes typically this lump would just sit there for the whole night shift, and that the whole production is just almost stopped because they're trying to process this one lump, and just a bit of a nightmare to deal with.
That's yeah. I mean, that's untenable nearly. To basically have a whole shift, not even just including then the wear rates that one rock is going to put on your machine, but just you've effectively got your machine doing nothing just from your rock shadowing. Um, all right, so let's go back then, Lee. If you had swapped the jaw out for, say, a cone or a gyro in those two applications, would that have fixed the problem?
I think you'd probably look at a gyro as in, if they're going to put that kind of lump size in. I mean, first question is, should they have gone a bigger jaw? I forget what size the jaw was, but and this comes into the selection criteria, right? Uh, you know, it's an interesting as an OEM supplier. You go in with the machine that you think is going to do the job. Your competitor may go in with a smaller machine because it's a lower price, right? And it looks like a great price up front. But once that machine goes in, if it can't handle it, then it's a big problem. Because if you've got a huge lump trapped in your machine, you've already wasted a night shift trying to process it. Then you've got to send your team in to get that lump out of there or deal with it. I mean, I've seen instances where they actually put explosives inside
Yeah.
and they blow the rock up inside the machine, right? Which is not very safe and not, but
If you got
that's,
no
I
rock
guess,
breaker, what are you going to do?
yeah, that's the consequences, right? Or you have to get operators getting in there with a jackhammer, right? Inside a machine. It's these are all the knock-on effects of not selecting the right machine for the job. So I guess circling back to your question, for me, if it's really sticky, if you're in that sort of 10 to 20% moisture zone, and the material is not overly hard, not I'm talking like 300 MPa, 400 MPa bond abrasion of like 0.2, 0.3. You got to be looking at a sizer for sticky applications. I think the only time you'd consider not a sizer if it's too hard or too abrasive, then yeah, you go for your default, your gyro or your jaw, depending on your size and your capacity. That's my view anyway.
Yeah, and I suppose both of those applications are probably talking primary sizes as well, because we're talking, that kind of wet sticky feed and also those big lumps. So first one, yeah, wet sticky feed sizer, 100%. Just can't beat that self cleaning action on the rolls. But second application where you're talking that big lump kind of sitting in there and chewing. Well, yeah, you're right. Maybe it is just an undersized machine, and it really should have been, the next size or two up, and it probably then didn't matter, whether it was a cone or a gyro or whatnot. Obviously, we haven't considered installation costs when we start talking about those things, and maybe that was one of the key drivers to put the jaw in the first place. But yeah, it's definitely interesting, and really, I find it really hard from my side as well. Sometimes the information that you get to try and pick a machine on, it's like we're always looking for more info. How can we make our selection better? And really hard to know, particularly because there's such a long duration between when the order comes in, machine gets manufactured, then it's put on site, and it's finally installed and finally commissioned. Years have gone by, and you're sort of going, you run into an issue like that, and all of a sudden it's just, whoa, hang on, why are we having this problem? Trying to dig back through everything, it's so tough. And in that time, particularly if it's a mine and their conditions have changed,
Yeah,
tough to manage.
It's easy for us to say, right? We've got the best machines. You should always buy the best machine. But I think sometimes it's not about, yes, it is about buying the best machine and a good quality, of course, right? You should always buy the best machine, but it's the best machine for the job, I think. So I guess, yeah, if we go on to the next one, like gyratory crushers. So let's, I guess, talk about gyratory and cones. So looking at like sort of that primary, secondary, tertiary. What's your thoughts on gyros?
I mean, gyros, particularly you talk about a lot of the big mining the big minds around, they've got to be a staple, right? It's their primary almost of choice. But I think it comes with a huge consequence. Some of these machines are massive, absolutely massive. And it's probably, if you're a well-oiled machine, you're a big player, you know what you're up for when you put these machines in. They're like 10 meters high. They weigh a couple of 100 tons. And you're designing that primary, basically your primary ROM station completely around that crusher. There's no feed. It's just your dump truck is just going to dump directly into it and just let it go. And you would hope then that they've got provision for, some kind of rock breaker or an overhead gantry crane with a rock breaker or an impactor attached to it. Great. It's not the first time it's been done everywhere, but consequence is like that ROM pad, how tall that ROM pad needs to be to satisfy putting that gyro in, reversing those trucks up to it is just a real money sink. So unless your geology really kind of plays into that. And then on top of that, maintenance, you can't move that machine. Once it's in, it's in. You've got to do all of your maintenance in situ where it is. So I suppose I don't think there's really good or bad in crushers. It's just differences, and you just play things off each other, right? It's, this is great for this gyro, great. It's in terms of handles the big feeds, can take the direct, ROM dump from your truck. You don't need a feeder, so you're going to reduce a bit of wear and maintenance in that regard. But then when you do maintenance, or if you have an issue, it's getting in that thing is a lot more challenging. You've got to be able to get inside the hopper and really do all your work in there. So that's kind of my experience with gyros anyway.
Yeah. Look, I think for high capacity, you're talking those sort of anything from sort of 5 to 10,000 tons per hour. The only machine that can rival a gyro on throughput is a sizer. But, if it's like a copper, it's a copper plant that's got, 300, 400 MPa, UCS, with a really high bond abrasion index, then you're not going to put a sizer into that application. It's going to wear out so fast. So realistically, your gyro becomes your default choice because it's the only machine really that can do that job. So you kind of like bet it's sort of like a bet of the devil, Well, it's the only devil that's available, right? So
exactly right. Yeah. What else are you going to do? You can try something else, but then you really don't want to be that guy that's kind of stuck either changing out teeth or other wear components every week or every couple of weeks if you've really just not got the selection right.
Yeah. Although having said that, again, they've got the limitations, and I think I'll come back to clay, sticky material. Gyratories do not like clay, sticky material. Actually had an experience of putting in the sizer into, again, a sticky application that, in the tropical months where, the gyratory would get bogged, they would actually divert their feed to a sizer. So they'd have a gyro as the prime, as a main. And then when it got into real wet season and it was really sticky and boggy, they'd actually divert the feed to the sizer station. And they'd run all the feed through the sizer because it was obviously better. So I guess to me, that was, that sort of validated that is a reason, that's the go-to when the material is too wet and sticky. You go away from the gyro and you go to a sizer. And that was a plant where it had two side by side, and they did that very thing.
See, that's, I suppose, what we haven't really mentioned there as well is because of the size of these things, they're really not being moved. You have to bring the feed to it. So, a lot of these applications, definitely, they're well set up to do exactly that. But, I mean, we were talking about not long ago a recent application for copper, which was not that. These guys wanted to be able to kind of move it along. And there was a real kind of toss-up between, do you go with sizer because it is more mobile compared to, another piece of kit? In the end, it didn't work out, whatever happened. But there's certainly some of these considerations that we really need to be engaged with the customer and discussing to try and get the best outcome for them, because what ends up happening is, well, you might just have really high transport costs because you've got to move this stuff so far compared to just being able to relocate it. And sure, you might have to sacrifice a little bit of downtime, but if you're doing the downtime, closer to where you're crushing or even closer to the pit, the benefit cost may start to work out in that regard.
Yeah.
But yeah, not a one size fits all, that's for sure.
Yeah, no, look, there's a very large copper mine in the US, and they have, I think they've done 2 or 3 gyratory relocations. It's a semi-mobile gyrator, so you can move them, but man, it's a big, expensive task to move those machines. It's really, really big. If you see typically a gyro, let's talk about cone crushers. Obviously cone, it's like a mini gyro really, but a next down the line.
Yeah, probably stronger then for the secondary tertiary then if we're talking cone v gyro. Whereas the jaws probably across a few more, but yeah, we're starting to kind of trend down the list. We've spoken a lot about primaries here, and it's probably time, we can start talking about secondary. And I think that's really where the cone probably starts to come in more to itself.
Yeah, definitely. I mean, my experience is seeing the cones on that sort of secondary, tertiary, almost like in tertiary applications. I've seen them installed, typically after jaws. I've seen them installed after sizes. Obviously, sizes, two rotating shafts, although obviously there has been quad roll sizes installed around the world. Essentially 2 rotating shafts, breaking material in shear, point loading those rocks. And as we know, sizes are really good for wet, sticky, soft to medium type materials. But obviously, I don't think the industry knows that sizes can do high throughput as well. I think a sort of not a misconception, but I don't think everyone's aware that the sizes are, producing a really, really high capacity. I guess, what's your thoughts on sizes, Bev?
Look, I'm probably in the same camp as you, Lee. I'm a bit of a sizer guy. I think they're hugely flexible. I think they're low footprint, and in terms of tonnage, you're right. For the right machine, they can really kind of start pushing up the tonnage, and they really can compete with some of those big machines. The downside, as you say, is definitely abrasion index. You start getting up there into those really abrasive feeds, and it's a challenge. And I suppose, I'm a little bit biased because that's been a little bit of a focal point for me lately with regards to the sizes and really trying to improve our offering and our range there. And toe-to-toe with that comes with all of the wear materials and things that come with it. So, if we're talking about sizes, 10, 20, 30 years ago, you're probably right. Nobody probably considered sizes to be a real contender. But mining's a fairly slow-moving beast. There's a lot of innovation there, but it's slow to kind of, in my experience, I think slow to adopt that innovation, being particularly risk-averse. And kind of circling back to your examples before, where if you do have a problem, if any one of these crushers does have a problem in situ, I think it takes a really long time to kind of work through that and either gain acceptance down the track once those issues have been sorted, or kind of re-adopt that technology if they've found improvements that kind of push the envelope and help them get what they want. Because at the end of the day, every processor just wants to turn a big rock into the little rock in the cheapest possible way, right? It's all about the economics of it.
This is where machines can get a bad name in the industry, especially machines that, relatively new, right? You take a fairly new machine, and I say new, sizes have been around since the 80s. Roll crushers have been around for 100 years, right? And really, realistically, a sizer is an evolution of a roll crusher. Really, it's two rotating.
It's a tooth roll crusher.
Yeah, it's a tooth rolled crusher, right? Okay, the drive system's different, slow rotation, high torque, where typically, roll crushers are faster rotation. But so let's take a technology like roll crushers, right? I guess the single roll crusher was an original McLachlan patent, right? So you go from a single roll crusher, an original McLachlan patent that's probably 100 years, let's call it 100 years old. I think it might even be 125 years old. The sizer is, in the 80s, an evolution of the double roll crusher, been around 100 years. Sizer is still considered to be new technology to the mining industry. How slow does the mining industry move on the uptake of some technologies, not all technologies, of course, we've got autonomous trucks, autonomous drills, there's some massive advancements in technology in mining. But when it comes to like crusher selection, it's very, very slow to take up the new technology. So I guess getting to my point is you put a machine in that's, been around for, let's say, 50 years, and is deemed new technology. One gets put into the wrong application and it fails or it doesn't work. Instantly, then that could be a number of people in that project team that don't like that machine. It could be a business, an engineer that doesn't like that machine. Then that machine then starts to get a really bad name. But it's actually not the machine. It's typically the person or the company that sold that machine into the wrong application, right? So that's why it's really important for us to get that selection right.
Absolutely. Or even just managing expectations. I mean, even if it is the right machine for the application. So let's say, you've got a high clay kind of application where you really do need a sizer, but your wear rates are still high. That customer engagement is, so vital to just getting that right.
Absolutely. Don't tell the customer your teeth are going to last 12 months when the teeth are going to last, 6 months, right? Manage that expectation up front and say, yeah, look, this machine is absolutely the right machine for the job, but this is what your OPEX is going to look like. And let the customer make that decision. Yeah. Yeah. I think the other thing, to touch on with sizers is they are super, super maintenance friendly. Typically now most sizers are installed with, motorized wheels. You can move that machine out into a maintenance position. You can access all the teeth really safely and easily. I think if you try and, you look at that versus a gyratory or a jaw, you're having to maintain those machines inside the crushing chamber. Whereas typically a sizer, you can move it out into a really nice, easy access position. Often, it's not a confined space. It's not working at heights. It's really, really simple and easy to maintain that machine. So, in a world where our safety practices are evolving rapidly, I think that it's probably one of the safest, if not the safest machine to work on and do maintenance activities. All right, so I guess we've talked about sizes, and without being too biased, I think let's move on. Obviously, we have just mentioned roll crushers, Bev, and I guess similar to a sizer. What's keen on your views on the roll crusher?
Horses for courses, I suppose. I mean, a roll crusher, if we're going to differentiate between a roll crusher and a sizer, you're getting down to these small to non-existent teeth, fairly smooth. In my experience, typically, I was surprised, I suppose, actually. We've got one experience where we were crushing, a lithium type product, and we were trying to hit kind of about a 3 mil. A couple of things really kind of stood out to me. Firstly was how quickly you start to approach HPGR territory. I'd expected that to happen at much finer sizes, crushing it a lot smaller than we actually were. So, we were crushing down to that level and found that the power draw really sort of started to ramp up probably getting close to about that kind of knee, even though we're not producing the same kind of conditions as, say, an HPGR would, with, the feed stream coming through, and you're really getting that kind of ribbon of material to compress through. So these were still kind of single particles, but yeah, it was starting to push it. So we ended up, we supported the customer. We got the machine going, upgraded some power and things like that. But it was a little bit unexpected, I think, from our end. But also materials like that, the salt and the plate-like kind of flaky nature sort of also kind of got me. But beyond that, I mean, roll crushers are, they do what they say on the box. They're there as a compression style crusher, great when they work. It was a wet application, so it was pretty good to work in that regard, specially designed. But yeah, they're the where sizes kind of came from. So that's it.
Yeah, I think it's interesting. I guess I just want to touch on some experience when you go in smaller and smaller and smaller in product size. The power's almost about, it's almost squeezing the material through. I've got quite a bit of experience in iron ore, and when you're trying to crush down iron ore, because there's that much fines in the feed, the fines are almost acting like a brake in the machine, and essentially you're trying to compress and squeeze through those fines, and it's not to be underestimated how much power you need when you're going down to that small size. So it's interesting that you mentioned that on I think was that almost like a small smooth roll size, or was it, or a roll crusher? That project, Bev.
Yeah, it's a smooth roll crusher.
Yeah,
I can come at it from a different angle.
Yeah, look, the power required actually when you're going down to such a small size, that's something where companies can become a bit unstuck, where you underestimate how much fines is in the feed and how much you've got to compress those fines and how much power that absorbs. Actually, we talk about, obviously we're selecting a crusher on the UCS, but the hardness, right? And it's the actual pick force that we talk about a lot. But yeah, the impact of things like clay, how much more power you need when you're trying to, again, it's trying to act as a brake in the machine. And it's similar with fines. High fines acts as a brake. So interesting with roll crushers, I want to talk about the speed, because obviously the way that they get their throughput, typically roll crushers are running a lot faster RPM than sizes. So I think that's the reason that the roll crushers are getting the small product size and getting the throughput is because they've got a very, very fast rotational speed.
Yeah. Which works well from an inertia perspective to help with crushing as well. It's not just about throughput.
Yeah.
But there's a little bit of I think, as I mentioned at the start of the show, I've got a bit of experience with a lot of different McLachlan systems. And I know, working with a lot of the US guys, there's in the sand division doing sand plants for frac sand. It's interesting. So I did a little bit of lab work with those guys. And when you're choosing a frac sand product, you're actually basing on kind of two criteria. There's sphericity and roundness. So how spherical it is, and then how rounded those edges are. It's really just talking about shape. But the whole point of the frac sand is it's to act as a proppant. So you want to send it down into the earth, and it's going to be propping open those fissures to allow whatever you're trying to extract to come through. So you kind of take that back to a crushing perspective. If you've got these really round particles, and when we spoke about shape, this is kind of how it sort of can become important as well. Round particles are chosen because they're just stronger, so they're just resistance to crushing is higher. So we're trying to come up from the other end, where we want to take these particles and crush them down. So there's a little bit of a draw card, I think, there for me, between seeing that and how we've manufactured those sands and proppants and things in the past because we don't want them to crush, and then here we are at the other end being, oh no, we want to crush those as well, and just kind of noting, I suppose, the similarity between the two distinctions.
Yeah, definitely. And it's funny. Obviously, we have that in McLachlan. We have that crossover. Obviously, we're on the mining division side, and we've got our aggregates division, and there is, we're obviously talking at this is a mining podcast. We're talking about mining equipment, and nearly on in the conversation, we talked about impactors. Me personally, I don't have a huge amount of experience with impact crushers, and probably because they sit more on the aggregate side and more, for sort of a limestone and that kind of application. We don't. This is a product that I sometimes talk about. Products that go in and out of fashion. And I think I mentioned in one of our other podcasts is like the wobbler feeder. It was kind of a really great product, sort of went out of fashion and then sort of come back into fashion now. Or as the impactor, it's got its place, but for me, you don't see them installed in that many mining applications.
Yeah, I tend to agree. I think when we're talking mining and we're talking about those, we'll call it minerals mining and those bigger plants, these types of crushers just don't get a lot of airtime. So I don't have a lot of experience directly with, those impact style crushers like VSIs and HSIs. Although I will say that, man, I've done a lot of weird and wonderful things for McLachlan. There was a VSI that we used. We were crushing glass to make sand, actually, for recycling, and that was probably the most experience I've got with one of those. And the biggest issue was actually dealing with the labels off the bottles. The labels from the bottles were actually causing a few issues with regards to the crusher because they obviously come in and kind of gum things up. So a couple of process changes, to wash those out beforehand, and then we're effectively making kind of manufactured sand, which was used in a kind of recycled concrete application. Call it recycled glass for concrete. But horses for courses, really, with some of these crushers. That's just and again, it's orders of magnitude different in terms of scale, in terms of feed, in terms of everything. And, it's such a broad topic when you're talking about different crushers and what they're used for. I mean, obviously, we're mineral systems here, so, we're heavily focused on the minerals and mining market. And that's just a small fraction, I suppose, of what's potentially out there and available.
Yeah, definitely. Thanks, Bev. That's a good, interesting story. It's I guess just very quickly touching on a couple of like recycling's a really interesting one, right? Quite often, concrete recycling is something that gets asked a lot, and that's fine. The concrete's fine, but it's the rebar that's in the center, so that's quite problematic, right? There has been sizes and jaw crushers used. You just got to be careful with the rebar. And I remember a tire shredding project some years ago about shredding tires. But again, if you've got any kind of like steel in those tires, it's problematic. So, but an interesting one, obviously we're focusing on the mining, but you do have those crossovers now and again. Between the sort of the aggregates, recycling and the mining, which is, I guess, beneficial for us at McLachlan, being able to cross over between, the different industries. I guess just to round out our discussion, we've been talking a lot today about mineral, but obviously one of our, parts of our business as well is coal, and many of our, products like sizes, are used effectively on coal. In fact, that's where kind of sizes started out in coal. But I guess a couple of machines that I guess want to just finish up on before we end our podcast is obviously first one's feeder breakers. Obviously feeder breaker being a combination of a chain feeder and a breaker drum or breaker head that we call it. Very, very popular, obviously, in coal, salt, and very, sort of soft, non-abrasive, typically non-sticky applications. Obviously, at McLachlan, Bev, you've had quite a bit of experience with our feeder breakers. So I'd be interested in your thoughts on the feeder breaker and where it sits in the mining industry.
Oh, look, I think the feeder breaker is possibly a little bit understated in how great they actually are. The ability, so there's a typical rule in process engineering where if you have a machine trying to do two jobs, it's not really good at either of them. And I would say the feeder breaker is possibly actually a little bit of an exception to that rule. Um, Particularly when we're talking about, so just in and of itself, a feeder breaker can come in many different flavors. You can have just an incline, you can have a like a gooseneck kind of version. We've done all kinds of versions throughout our history, kind of thing. And it's just to really kind of understand the impact it can have. Just a feeder breaker itself obviously eliminates the need to have a feeder and then some kind of crushing plant. So it's acting as your primary crusher for any plant. So first up, there's a bit of a win there. That's a win for overall plant height, as well as just the equipment and everything you've got installed. Really good. And then the fact that you can make that gooseneck style. Well, now you're talking about ROM pad height, and really, we spoke about kind of crush ratio before. So a feeder breaker as well can take those really big lumps, make them a really suitable size for downstream plant equipment. So you've got wins for ROM pad height, wins for it can handle the tonnage, wins for multiple machines in one, and it's really kind of a fantastic machine for what it does. It does it well. It does struggle with the higher abrasivity feeds, so really abrasive feeds are gonna hurt it. And that's why it typically does get used a lot in the coal, the limestone, the salt. We're seeing it even beyond those applications, coking coals and coking applications, and then after coking plants have been through turning some of their the coke itself, breaking that down. We've seen a few applications, but yeah, it really is limited to lower abrasivity type applications. But for what it does, it's a great machine done well, definitely.
It's interesting, obviously, being 3 years in at McLachlan, feeder breakers were something considered to be like, it almost, well, let's say cheap and nasty, but I think a lot of companies in the industry have referred to it as as almost like what's like lesser, like a not up to the gyratory or the sizer kind of world, but actually like the advancements that I've seen that McLachlan have taken this feeder breaker that probably was and a lot of equipment back in like the 80s or the early 90s was not particularly great technology, but I think what I've seen, just if I was standing back as an outside point of view, the advancements of the McLachlan feeder breaker, and not all feeder breakers, like not all crushers are equal, right, across different competitors. Not all feeder breakers are created equal or designed equally, because our feeder breaker has been taken to what I think is probably the best feeder breaker on the market, purely because of its advancements in technology, its wear life, its maintainability, and its robustness. That I think it's actually a class A product now, and it's proven because it's the go-to choice in coal mining applications for the primary crusher. So yeah, I think it's a fantastic piece of kit.
Even just in the history of what we've been doing here, particularly in Australia, a lot of the wins that we've had is actually in displacing what were typically considered to be three-stage crushing plants and taking them back to two. So we
Mm.
talk about that crush ratio and really just being able to hammer those really big lumps and get them down to a suitable size for the secondary. And we spoke about earlier where the three different crushing applications. The feed is the product, or the feed contains the product. Sorry, the product is in the feed. Yeah, this is really an application where the feed is the product. So we're still caring about controlling fines. We're still caring about controlling over and undersize. The coal industry is no different than a lot of industries. They've got specifications they need to hit with regards to, the shape and size of those particles. And the fact that you can displace an entire crusher from a circuit and take it back to two-stage is really, like, that's a real win for the customer's bottom line. Not just in terms of OPEX, but CAPEX. It's one less machine you've got to maintain. So many benefits. And then you couple that with reduces in ROM pad cost, because now your overall plant structure is a lot lower. Not just because it's a feeder breaker or an incline feeder breaker, but because you don't have that machine. Like, it's just absolute game changer, I think, for a lot of plants, and particularly, as you say, Lee, where it was typically viewed to where its strength lies, which is that real kind of primary application of taking those big lumps, put them into that really kind of specific size group suitable for the secondary, whilst not making too many fines, whilst controlling all of those things and being able to handle the mining duty that they do.
Yeah, no, and you make a good point, right? And you think about going from, if without any compromise, if you can go from a 3-stage crushing circuit to a 2-stage, that's one less transfer, one less crusher. The actual, if you looked at that side by side on a fines generation, you would have far less fines generation on a 2-stage system than a 3-stage system. From the coal industry, that's all about, you want to get down to a specific size by basically producing as minimal fines as possible, because fines, it's not only waste, which again, it's problematic, right? Because then if we look at further down the circuit, more fines, you're having to deal with that, and obviously you being one of our wet process experts on thickeners, you know all about that, right? You're creating more, you're sending more fines, you're sending more waste to that back end of the system. It's even bigger of a problem, right, to deal with, and more money.
Absolutely. And it's a valuable product to lose as well. You're talking about lost products. So it's not just about dollars per ton to process. You've got to then recover those tons to be able to sell. So every ton that you lose is lost opportunity effectively. Yeah, it really does lend itself to controlling fines is in the right application exactly what you should be aiming for. But then really trying to understand that balance is fantastic for helping process engineers as well, because they got to design the different circuits. Every time you split off a feed stream, everybody's always concerned about, okay, how many tons are going this way or that way, and really it starts at the crusher and understanding those partitions and feeding them off, and by the time you get down to tail end of the wet process stuff, it really can matter. So it's just something that we've really got to be on top of, and that's definitely a focal point for us. Certainly tell my team, we care about crush ratio, because crush ratio for me is about, you want to, as efficiently as possible, turn those big rocks into little rocks. And if you can displace an entire machine, go from 3-stage to 2-stage crushing, we just spoke about how immensely beneficial that can be to any plant, doesn't matter what you're processing. And then really understanding our fines generation. Sometimes it's important and sometimes it's not, and that partly comes back to selection, but also there's a lot of design aspects there as well. So yeah, we put a lot of effort into those two key things. Definitely they're front of mind every time we're looking at any kind of machine that we're designing.
And that's interesting, Bev, that, because you talk about selection criteria, right? And I kind of bang on about this all the time. And you mentioned it earlier in this podcast, is information. As much information as possible, more information, as much information as possible is the best way. Things like, what's the infeed side? Have you got an infeed gradation? That makes a massive difference. What product size? What is your product size? And when I say product size, we need 50 mil or we need 100 mil. Is that like, have you got safety factors in that? Because that 20 or 10, 20 mil difference changes the selection of the crusher. So it's like, right, okay, what's your next downstream process? What's the limitations of that? Are you telling me 100 with a safety factor when really that machine can do 150? well, if that machine can do 150, that makes my selection up here. I can make a better selection, which is lower OPEX, lower CAPEX perhaps, or maybe it's higher OPEX or CAPEX. You know, that really informed information on the next piece of equipment in the process is really key to making the right decision. You know, and then other things like, you know, how hard is it? What, you know, okay, it's 50 MPa, right? It's 50 MPa, but nominally is it, you know, 80% of your feed 30 MPa and 5% of it's 50 MPa, and just the more granular you can get on your information or more detailed can make a massive selection, as you know.
And even just beyond that, it's hard to. I mean, sometimes people don't even realize some of the averaging they give us when they give us information. So they might say the feed is, I don't know, 50 MPa or 80 MPa. But then is that just the feed, or are you talking about the feed and the contaminants, or just the contaminants? Understanding those things can be really, really vital as well in us understanding the correct, to make that correct selection.
Absolutely. You know, because also, you know, it may be your contaminant may be 5%, 1%, 50%, right? And if your contaminant is 3 times, 4 times harder than you know, your nominal feed, that makes a huge difference on your power calculation, as you know.
Yeah, one of the best pieces of information I ever received was someone gave us, you know, we talk about abrasion index, and again, that's another one that gets kind of averaged out. But we were given abrasion index by mineralogy. So, I mean, that was amazing to just kind of see that level of detail where someone had given us, oh, you know, we've got this kind of feldspar and it's going to have an abrasion index of this. And then, you know, it's going up to some other, you know, quartzite kind of thing. And then it was abrasion index of this. And just being able to really kind of knuckle down and really get in the weeds of that was just beyond amazing, particularly for someone who's, you know, I'm an engineer, so I like numbers and I like information. So, you know, to have that kind of information at my fingertips was just amazing, to be able to do a selection and really kind of work with the customer and go, oh, okay, I get what you're working with now. It's not just somebody else has already taken the data and cleaned it for me and then not given the context around it.
All right, Bev. Well, thanks very much for your time today, mate. I think we'll wrap it up there. Any closing thoughts from yourself?
Oh, look, I think we probably got into enough weeds here today. It's probably sufficient to say that crushing ain't crushing. You know, we barely even touched on, you know, removing overburden. We barely touched on so many other aspects that we probably could have spoken about here today, and even probably a few other machines. But look, I really appreciate the chat, mate. It's been good. Yeah, and I think that'll probably do for now.
Well, the listeners can look forward to maybe part 2 and part 3. Hey, what's the saying? The sequel's always better than the first, right?
Hopefully just as good.
Oh yeah, fingers crossed. Thank you for listening to Groundwork, McLachlan podcast. Be sure to subscribe on your favourite listening app for new episodes, and follow McLachlan on social media for more content. Thank you very much.